So today we're going to do adding and subtracting with unlike denominators. And don't forget that it's really important when you add and subtract that you do have common or like denominators. So we're going to have to be able to find what the least common denominator or LCD is. Sometimes people refer to that same thing as LCM. So we're looking for least common denominators or least common multiples. And essentially what that means is you want to balance out these particular denominators so they both have the same thing. And if you take a look at number 1, for example, if you see the number as 5 and as 8, well, what number do they both go into? And they both end up going in this case, into 40. So part of our least common multiple would be 40. In terms of the variables, what I'm looking for is the greatest power of any variable that exists. So in this case, my x's, I've got x squared and x to the first. So x squared is going to be part of my common denominator, or my common multiple, if you will. And they both already share y cubed. So my least common multiple, in this case, is 40x squared y cubed. What I'm actually doing, I'll back up just a little bit, is the least common multiple of numbers. You're looking for the smallest number that is a common multiple of both of those numbers that exist. And for the variables, you're looking for the largest power of any variable that exists. Okay, so for the next one, between 6 and 9, well, what's the smallest number that they both can go into, or that they both go into, and that would be 18. So in this case, I'm going to have 18. And then in terms of the variables, there's a's. The least common multiple of a's would be a cubed, because I can't take away variables, but I can add variables. In terms of the b's, I've got b to the fourth, and in terms of the c's, I've got c squared. So the least common multiple, or what will be turned into the least common denominator of that problem, would be 18 a cubed b to the fourth c squared. Here's how this stuff actually works. When you add or subtract fractions, find your least common denominator. Very important. The second thing, you're going to change each fraction, each rational expression, into an equivalent expression with the LCD as a denominator. So change each fraction if necessary so they have the LCD. Add or subtract just like you normally do. Just be careful though, you might need to do keep, change with subtraction and then simplify. So what happens on this first fraction is I've got 3x in the bottom and 6x in the bottom. Well, the x's are already balanced out, which is great, but 3 and 6 are not the same number. So the least common denominator in this case would be 6x, because I can multiply this first fraction by 2 on top and bottom, and my first fraction now becomes 14 over 6x plus 3 over 6x. You didn't have to do anything to that second fraction. And now what ends up happening is 14 and 3 are like terms, which give you 17. 6x is your common denominator. It goes back to what we did the other day, and now nothing else can be simplified from here. If I look at the next problem, I've got 6 over 5x minus 4 over 3x squared. In terms of the numbers, 5 and 3 aren't the same, but they both can turn into 15. X and x squared aren't the same, but they both can turn into x squareds. So my least common denominator is 15x squared. So what has to happen is the fraction on the left needs to be multiplied by 3x on the top and on the bottom, and the fraction on the right just has to be multiplied by 5 on the top and the bottom. So what happens is my common denominator stays as 15x squared in both fractions. My top one becomes, or my first fraction becomes 18x. My second fraction just becomes 20. And I'm being asked to subtract these pieces. If I write it as one big fraction, here's my common denominator. 18x and 20 are not like terms, so I can't really combine them, but I can keep it as 18x minus 20. As it turns out, this binomial up top does have a GCF. I can factor out of this top here, I can factor out a 2 and be left over with 9x minus 10 over 15x squared. and the monomials don't simplify any further, that's your final answer. Let's try another one. This guy. In terms of my numbers, they can both turn into a 14. In terms of my letters, they need to have an x and a y. So the least common denominator becomes 14xy. Well, how's that going to happen? I can multiply this fraction by 7y, top and bottom. I can multiply this fraction by 2x, top and bottom. So what ends up happening is both bottoms now become 14xy. I'm just going to write one fraction this time. And then I'm going to say, well, the one in blue turns into 77y plus the one in green turns into 8x. I don't have anything common up top. So I'm going to write my answer all in one color, not for any particular reason, but it's going to be 77y plus 8x plus 8x all over 11xy. Nothing can be simplified from here. Let's try another one. Alrighty, so this one now, in terms of my least common denominator, I've got an n and a 4n, which means they both can become 4n. What happens now is I also have these binomials on the top, so you got to be really careful about that. And you also need to understand that we're going to be doing some keep, change, because you're subtracting that whole polynomial. So we'll worry about that in 1 second, but I do know that the only way to get 4n on this left fraction is to multiply both top and bottom by 4. So what happens is my common denominator is just 4n. My left fraction becomes 4 times the parenthesis of n plus 3, and I'm minusing the parenthesis of 4 minus 8n. I can't forget about the distributive property, which means it's 4n plus 12. And now be careful, this is like a -1. This negative sign has to go all the way through, and then it becomes minus 4 plus 8n, all over my common denominator. Well, you do have like terms. The n's total out to 12n. The numbers without n total out to 8. All over 4n. Again, all we did here was look at 4n to 8n, and then we looked at positive 12 minus 4. There is a GCF on the top. I can factor out a 4 being left over with 3n plus 2. On the bottom, I've got 4n. And these monomials can wipe each other out with a final answer being parentheses 3n plus 2 over n. Make sure you're good with that before you move to the next one. Okay, let's see. Let's go to the next one. In this case, we still have binomials up top, so it's always a good idea to get in the habit of putting parentheses around those. Your common denominator, hopefully you realize, is 3a, which means the only fraction that has to be messed with is the one on the left. So common denominator is 3a, and I'm going to have to distribute 3 into this parentheses, a plus 1, plus this parentheses. So then I really get 3a plus 3. Fix that. 3a plus 3 plus a minus 3 over 3a. Like terms will tell me that I've got 4 a's. These guys are inverses, so those cancel. 4a over 3a, and then the final answer just becomes 4/3. Okay. 6. Here's where we probably get the hardest. Again, in terms of the binomials, now that they're on the bottom, make sure the binomials have parentheses around them. What happens is binomials happen to be a package deal. So the LCD has to have each parenthesis. It's going to be an x minus 5 parenthesis and an x plus 2 parentheses. What's going to have to happen is this guy on the left has to be multiplied by an x plus 2 on top and bottom. This guy on the right has to be multiplied by an x minus 5 top and bottom. I'm only writing it once now, but it's got to be multiplied by top and bottom. That's what gives you the common denominator, x plus 2, x minus 5. And then you have to realize that 8x has to be distributed into what it needed, minus 3x has to be distributed into what that side needed. Okay, so we've got to do some distributive property here, which is going to become 8x squared plus 16x minus 3x squared plus, excuse me, 15x all over x plus 2, x minus 5. And then you finally combine like terms, x squareds turn into 5x squareds, x's turn into 31x over x plus 2, x minus 5. Last but not least, I can factor by GCF up top. X comes out of a parenthesis, 5x plus 31 is left over. The denominator is x plus 2, x minus 5, and that's your final answer. Definitely more complicated when you have a binomial in the denominator, because then you end up having to multiply either fraction by another binomial, which causes distributive property. Let's see. I believe that is it. So for the homework, you should be all set. All right, good luck.